Hello, welcome to Majestic Easy World Science channel, the easy world of science. Thank you for visiting again. Thank you if you have subscribed to this channel. To my great followers, more love, much love from me to you. I cannot do without you. Let us keep sharing. When I look at my weekly recap, I discover that my followers can share my videos well, and I appreciate you guys. I might not know you, but God knows you. So I really say thank you. Share my videos and look for other scientific videos. Remember, this is Her Majesty Easy World Science channel, not exam channel. And the Nigerian system and African system of education is not practically oriented as usual. But let me go straight forward to the point. I'll be analyzing zinc chloride and then make powder theoretically using the list of specimens provided. So you will see the table, comprehensive table that will have test, observation and inference on the analysis of these two samples. Looking at the reagents that are made available for us, if you take a look at zinc chloride, one, we think straightforward that we must be tested for zinc ion, and secondly, we might probably test for chloride ion. Why did I say probably? Because I did not see silver nitrate solution or lead 2095 solution in that reagents provided, which means the test for chloride ion might likely not occur. But I will teach you that just in case, because we're analyzing zinc chloride. Then milk powder dissolved in water, that's milk solution. People are wondering, including me, what are they going to do with this? But first, just know that there will be tests with litmus for both zinc chloride solution and that milk. So zinc chloride, due to salt hydrolysis, we have an effect on litmus paper. Then which of the litmus paper will it affect? Is it red or blue? Look at it. Zinc chloride is a salt of weak base, which is zinc hydroxide, and a strong acid, which is a hydrochloric acid, HCl. How do you know the acids and the bases that form a salt? Just remove the metal or the cation and replace hydrogen, and replace it with hydrogen. So if you say zinc chloride, what must you do there? Remove the zinc because that's the cation, place hydrogen there, it forms HCl. Then if you want to know the base that formed it, remove the anion and place OH there. So zinc chloride, if you remove chloride ion and place OH there, it becomes zinc hydroxide. And zinc hydroxide is insoluble. Remember, all the insoluble bases are actually weak bases, of course. So zinc hydroxide is a weak base, while HCl is a strong acid. Therefore, the salt zinc chloride will behave like an acid in aqueous solution. This means that the solution of zinc chloride will turn blue litmus paper red. Remember, while testing for solutions, you don't need to moisten the litmus paper because you are already putting it in aqueous solution. It's only when you use it to test for gas that you are required to moisten it. But milk is expected to be neutral or slightly acidic theoretically, but practically the milk powder I have been obtaining are slightly alkaline. As you can see there on the screen, I use my pH meter. Shockingly, I'm observing 7.4, 7.5, even 7.3 is what I'm seeing in the milk. They sell outside there, especially the sachet one I bought. So that is it for the thing. I wouldn't know if we're going to report practically or, but when I browse, I discovered that milk is expected to have 6 point something, 6.8, 6.4 as the pH, which means because of the lactic acid. But unfortunately, the ones obtained are slightly alkaline. So now, in that vein, let me now teach you zinc chloride. Remember, zinc, aluminum and lead have similar behavior with sodium hydroxide because they are all amphoteric metals. In other words, their hydroxides are amphoteric, which means their hydroxides can behave as both a base and also as an acid. Ampho is a kind of it is having dual, gotten from the Greek word amphi, just like you see in amphibian in biology. So that's dual life that lives in water and comes on land, but amphoteric now, acidic and basic properties. So in test for zinc ion, we need sodium hydroxide. You'll be required to add sodium hydroxide in drops and in excess. Remember the table of test and observation, well typed. You see it on the screen after this little guidance. So you'll be told, remember, if it is NECO, there is nothing like question. They make tables for you, fill the test for you to fill the observation and inference, or less they change. But for now, this is their pattern, I know. Okay, So, but WAEC could give you the questions for you to make table, draft your tests, then make your observation and inference from the questions they give you. Okay, I will be running in the case in every in both ways. So you might be told to add definitely dissolve sample C in water, which is zinc chloride, and stir, test with litmus. You say dissolves to form a clear solution. Solution turned blue litmus paper red. Solution of C, that's under inference, is soluble. Then solution of C is acidic because it turned blue litmus paper red. Okay, remember the color of litmus in acid is red. Now you will also be required to divide the portion into 2 or 3, but I'm suspecting 2 only. So the first portion, you might be required to add sodium hydroxide in drops and then in excess. If you add sodium hydroxide in drops to a sample containing zinc ion, it will give you white gelatinous precipitate. White gelatinous, meaning it will be sticky to the walls of the test tube. Then, if this happens, you are going to suspect zinc and aluminum. Of course, don't put lead since you have said gelatinous. So, and the precipitate will dissolve in excess of sodium hydroxide. So, under inference, you now write zinc or aluminum present or zinc or aluminum likely. Don't write lead because lead is chalky or powdery. Then, to the second portion, add aqueous ammonia in drops till excess. You will report exactly the same observation you saw with sodium hydroxide, meaning if it's zinc ion is present, you are going to see white gelatinous precipitate in drops, PPT dissolved in excess, or you say precipitate dissolved in excess aqueous ammonia. Your inference this time around is zinc ion confirmed. Why are we eliminating aluminum now? Because of the reagent we used. The reagent we used in the first one was sodium hydroxide. So aluminum and lead have similar behavior with sodium hydroxide. But the second reagent is now aqueous ammonia. It's only zinc that forms white gelatinous precipitates with aqueous ammonia and dissolves in excess of it because zinc is transitional. It's a transitional element and then aluminum is not. So zinc have the ability to form complex ion, which led to the solubility of that zinc in excess sodium, in excess aqueous ammonia, forming tetraamine zinc ion. That is the complex formed. But this cannot happen with aluminum. So aluminum don't have that property of forming complex ion like zinc does with aqueous ammonia. And remember, aqueous ammonia is a perfect Lewis base, meaning it can donate a pair of electrons. So because of that, it's a perfect ligand. It donates a pair, which makes it perfect for formation of coordinate covalent bonding. So now, just in case you might be asked to test for chloride ion. Test for chloride ion, you can do it in 2 ways. Either you are using 2 pairs of these reagents. I will give you 2 sets of reagents. The first set is using HNO3, lead-2 triazole plus heat and allowed to cool. So when you add HNO3 to a known sample, you are going to see no visible reaction. And then when you add lead-2 triazole there will be white chalky precipitate, which will dissolve on heating and reappear on cooling. In your inference, you write chloride ion confirmed. Then if the second set of reagents that are possible to be used for determining the presence of chloride ion are HNO3, silver nitrate this time around, no more lead-2 triazole silver triazole and then excess aqueous ammonia, no more heating. So it is either you use silver triazole with HNO3, that's all in aqueous, and then excess aqueous ammonia, there is no heating and allowing to cool. So what will be our observation in this second set if chloride ion is present? You say no visible reaction with HNO3, white chalky precipitate formed with excess silver triazole precipitate dissolves in excess aqueous ammonia to form a clear solution. Your inference will be automatically chloride ion confirmed. So the chemistry behind all these processes, in the first one we use lead and HNO3. HNO3 is to prevent the precipitation of other insoluble sources of lead-2, while the lead-2 there is to precipitate the insoluble lead-2 chloride, because it is established that lead-2 chloride is insoluble in cold water but soluble in hot water. So that's the only chloride that behaves that way. So when you add lead-2 ion into an unknown sample and it gives you white precipitate that dissolves on heating and reappears on cooling, it shows that that unknown sample contains chloride ion, and the compound that dissolves on heating and reappears on cooling is lead-2 chloride. Okay, then in the second set, using HNO3, silver nitrate, and aqueous ammonia, the HNO3 there is also to prevent the insoluble salts of silver, such as silver carbonate, if such as carbonate ion, if carbonate ion is present, remember that silver carbonate will be formed. But when you add that HNO3, it will go and dissolve it. HNO3 cannot dissolve chloride ion, of course, but it will dissolve carbonates, because silver carbonate is insoluble. Lead 2 carbonate also is insoluble. So in case of silver nitrate, you say HNO3 is to prevent the precipitation of other insoluble source of what? Lead. I mean silver, other insoluble source of silver. Then that is just the chemistry behind that. We go to milk. We were provided with soda lime and 2 molar HCl and milk solution. Now let us coin the exact thing that will come here. You will be told to add that 2 molar solution HCl to milk. That will lead to what we call coagulation, as you can see there on the screen. That is coagulation of liquid milk, turning it from that liquid to insoluble particles, and this is what we call curdling of milk. And this enables digestion in the stomach. Remember, the stomach is acidic, so the acidity of the stomach automatically supports coagulation of liquid milk by changing the soluble protein to insoluble protein. That's converting carcinogen to casein, of course, but this should be more treated in biology. But here, just know that when you will be told to add 2 molar HCl to milk, you say curdling or coagulation occur, or insoluble precipitates occurred, and you say decrease in pH induces coagulation of milk. So reducing the pH will automatically induce coagulation. But if you add soda lime will increase the pH, and milk will not coagulate at that pH. And this is why I think these commercial milk tend to make their own slightly alkaline. It is safer, and again that 7.4 is equivalent to the pH of blood. As you are consuming it, it will not contribute in acidosis or in any alkalosis. You know, when somebody has peptic ulcers, some might advise you to take milk. But unfortunately, in real sense, if that normal milk should remain 6 point something, it is going to worsen your condition if you're an ulcer patient. But the commercial one that I noticed now that I have 7 points, probably to match with the internal environment, which is 7.4, that's the pH of blood, so that it will not either increase or decrease the pH, keeping it is helping the body to be homeostatic, that is in case of pH regulations, which is done by the kidney. Okay, so just know that when the soda lime is added, of course, adding soda lime to milk and asking you to test with litmus, definitely soda lime is alkaline, and automatically the milk will be forced to change red litmus paper blue, because now it's alkaline in nature. But when you add HCl to it, there will be curdling, there will be formation of insoluble particles. If you are adding litmus paper there, just know that it will now behave as an acid because of the HCl you added. And our stomach, like I told you, produces this HCl, which helps the renin also together in coagulation of liquid milk, especially in the mamas that are still breastfeeding. Okay, so these are the few guidelines I'll give you. Remember to share my videos. Please subscribe, expand this science community, and contact me for your industrial production processes, quality control. I am an analyst. If you go through my videos, you will confirm that, not just only for examination. So I am a kind of busy this time. That's why I didn't demonstrate most of these things I'm saying. And you can watch them. I have videos on this analysis on zinc ion, all the cations possibly, test for gases, test for anions, many of them. But do you know our problem as Africa? You click this video because it's just for exam. After exam, only God knows if we will see you around. But hang around. Her Majesty have a lot to give you in science, not just for exam. Please, let us love science. Subscribe and share this video. Much love from me to you. Bye for now.
Hi, I wanted to tell you that you can contact Her Majesty is the World for your laboratory equipment and reagents. They are affordable and provide accurate results too. Her Majesty is the World only sells what he knows, and his patterns of delivery are sure and certain. Place your orders today. Thanks for your patronage. Wait a minute. Have you heard about the Majestic table? It was designed and recommended by Her Majesty himself. Here it is. The amazing thing about the Majestic periodic table is that it provides a clear and colorful classification of elements from P block metals to metalloids to liquid metals. It also shows the boiling and melting points of all the elements. It also has the unique feeling of electrons in the shells of each element.
To enhance the easy learning and teaching of chemistry in schools, in universities, secondary schools, in research institutes. So this Majestic periodic table, demand and special demand, as you can see that space there highlighted, that is where you can include the name of your school, or if you are dedicating it to anybody, you can write there, because you can print it to any size you like. In a Majestic size, the resolution will never be affected. So it took me about 3 months to design and provide these informations, but thank God the table is here. What made me to design this is that I discovered that these tables I see in the internet, the one I see in the market, they are not as informative as I want. And then some of them are not updated. Some still retain the fact that we have, there are like, some still see promentum has not been radioactive. Some might see them as artificial element, but it is still is a naturally occurring element, of course. So there are some modifications that this table has been made to include, and that makes it Majestic.